One thing that is interesting about object-oriented programming is the idea of encapsulation. So you've probably heard this concept before. Encapsulation basically means that if you define a class, you will want to have some methods that are private and fields that are private and that are not exposed to the outside. So you don't want to expose internal details of your implementation to other classes. And no other class should be able to call a private method or access a private value. If we look at JavaScript, if I just say that I want to define a class, and this class will have a field which is name, and I will say my name, and then if I try to instantiate this class, nothing happens. If I say foo.name, I get my name. So we can see that by default, attributes in JavaScript, in a JavaScript class, they are public. So this wouldn't be possible in a language like Java or C#. If we look at this page right here, they're talking about how you can emulate private methods with closures. So they're saying that before classes were invented, there were no way to declare a private method. Actually, right now there is. So if I'm not mistaken, I think it's this notation right here. If I run it, we see that nothing happens. So right now we see that this notation indicates that field is private. So therefore I can't see anything here. If I try to call this name like this, we see that it's undefined. So basically, since it's private, we couldn't see it, and now we can. But this is the class-based approach. But before JavaScript introduced classes, usually classes were defined using functions like this, and we see that it works the same way. So I can instantiate objects this way. I can create instances, but I'm using the function keyword instead of a class. And we still see that the name is public. So in object-oriented programming, you would call this a public attribute. If we go back to this page, we can see that, so they're saying that before classes were invented, there wasn't a native way to declare a private method, but it was possible to emulate it using closures. So this is another use case of closures. So they're saying that private methods aren't just useful for restricting access to code, they also provide a powerful way to manage your global namespace. Say that you don't want to create name collisions. So if you define variables, you don't want them to collide. So you want to be able to isolate some of your variables in one place and not make them collide with other variables. If we look at this example, so it's an interesting example. They're basically creating this expression right here, where they wrap a function in parentheses, and then this counter is actually an expression of a function that is wrapped within parentheses, and then it's invoked. And this is usually called an IIFE or an IFE, so an immediately invoked function expression. So the result of this invoke would be this object. What's interesting is that it will be an object which contains a bunch of methods, and it also references, or one of these methods references an outer variable which is stored in this closure. So this means that this will be stored in the memory, and what's unique for this is that it will be private, so it will not be accessed from the outside. So you can never write counter.private counter. That would not work. So this means that we have achieved privacy, data privacy and encapsulation with the help of closures. So let's try to simulate this. Here we have this function. I'm assigning this variable like this. If we run it, we see that the attribute is is public, make this a private variable. And right now it's not doing much. And this will be a function, an anonymous function, which doesn't take in any parameters, and it should return the variable. So if I now run this, we see that it's undefined because there is no property on this instance. But if I say get name, if I run this method, then I can get the variable. So I could, for instance, say blah blah to see what that is, and it is blah blah. But still, if I run bar.getName, I still get my name. So even though I could override the name field, I'm not actually overwriting this variable. It's just a field on the instance. So I'm still achieving encapsulation. So the actual name that I want to store is private, and it's not accessible from the outside. I could write things here, but as I said, it doesn't override the actual field. In this example, they're actually returning an object like this. And I mean, there are different approaches to achieve it, but the important thing is to understand that I should be able to use private methods, and I should also be able to update them. So let's try to do that instead. So make the counter instead, and I will say new counter, and this will be called counter. And I want to say counter, and that will be assigned to 0 initially. And then I want to have an increment. And what it should do is to say this, or it should just say counter plus plus. So now if I say counter dot get value, I should get 0, and I am getting it. So that's nice. If I say counter dot increment twice, we see that it's 2. So we see that we can update this variable, and it's stored in memory, as I said, due to it being a closure. And I can't say counter.counter because that will be undefined, because there is no attribute, as I said. It's a private variable inside of this closure or inside of this scope. And I can also decrement it 3 times, for instance. So we should get -1. So now it's -1. So we can see that we are achieving the encapsulation, which is one of the principles of object-oriented programming. We can achieve that through creating a private variable and using the closure to access the variable inside of the function and update it, but still not expose it to the outside. So no one can override this variable or mutate it in a way that we don't want. They can only use these public methods.